Welcome back to our informational series of short videos where we discuss topics for customers and colleagues that take a little more explanation. We hope you're enjoying them. Please follow us on social media for other episodes. And as always, thank you for joining us.
Hi, I'm Tim Burke, CTO of Arch Systems, where we specialize in custom hardware and software for data analytics and excel in guiding predictive maintenance and machine learning. Today we're talking about the hidden cost of data silos and what that really means. Electronics manufacturers generate incredible amounts of data, some of which has been collected and used in their operations for a long time. With Industry 4.0, there's an increasingly validated and evidence-based belief that combining data from existing silos with new sources and modern machine learning tools will yield massive ROIs. Yet, despite their efforts, many organizations have discovered there are unexpected practical challenges and pitfalls to making this process work at scale. Primarily, this is because the process is often exploratory, and you don't know if any specific effort will pan out. You just know that hidden, somewhere, in the data about your factory are industry-moving insights, and you want to find them before your competitors do. In many cases, the limiting factor for how quickly you can solve problems with data is how quickly you can put together a clean, unified dataset. Once you have clean data, it's straightforward to get value from it. This is where the hidden cost of data silos lies. The first thing we often hear from new partners is, we have the data. What we need is data science to solve a problem. When we dig in though, we tend to find that while they have, indeed, collected a lot of data, it's stored in many different systems for different purposes. These are data silos. And data science alone can't fix the problem. To understand why, let's look at a familiar analogy that SMT experts will recognize, the pick-and-place machine. Say you have a pick-and-place machine that can place 50,000 components per hour, and a customer wants you to make a single board with 10 resistors on it. They give you a printout diagram and a little ESD baggie of the resistors. The customer wants to know how long it would take to build this one board with your state-of-the-art pick-and-place machine. As most everyone knows, for a single board with loose components, it's probably faster to just solder it by hand than to spend the hours programming the pick-and-place machine to then spend 1 second placing components on the board. That's because the prerequisites that enable your pick-and-place machine to work so quickly are a standardized problem description in a machine-readable format it can understand, standardized components on carefully configured reels or trays to minimize the component-to-component variability during pickup. The industry has had many decades to build careful standardization around a pick-and-place process because it's critical for a reliable, high-speed manufacture of all circuit boards. For Industry 4.0, the equivalent of the pick-and-place machine is machine learning algorithms such as the deep neural network. Data by nature is valuable in mass quantities, and it's what makes machine learning valuable. For machine learning to function, it has two prerequisites. One, a standardized machine-readable problem description it can understand, and two, standardized and sanitized data inputs that have very specific regular formats. Modern machine learning tools struggle to deal with tiny variations from one data entry to another, variations that inherently exist from one data silo to another. As the number of silos goes up, the process of unifying the data within them becomes more complicated. It sounds like it should be easy to just put all the data together and then do the data science, but it's not. That's because solving the same problem at a small scale turns out to be very different from solving it on a massive scale. On a small scale, you can deal with edge cases manually. For example, if you have 100 rows in your spreadsheet and 1% have issues, it's not a problem to just fix that one issue. However, a 1% issue on a spreadsheet with 10 million rows results in 100,000 problems. To deal with these manually is not only expensive and inefficient, it's likely cost prohibitive. In this light, the real hidden cost of data silos comes into focus. It's not that you can't get data out of them or that it's impossible to combine data from multiple silos to solve a problem. It's that it's a non-trivial amount of work to do so every single time. Without the right tools, you naturally stop doing it unless you're very sure it's going to be worth your while. As a result, many problems never get solved, even if the ROI could be large, because the cost of finding out if you're right is just too high. Reducing the cost of unifying data across silos pays dividends throughout the organization because it reduces all data problem-solving barriers. Data is increasingly being used to solve process issues. With automation in place, and with the right tools to properly tee up the data, it's an open lane to increasing return. That realization is a key step toward unlocking the factory of the future.